Hey everyone! In this video we are going to rig the eye using Wix. The rig is based on a blog post by Chris Lesage, who rigged the eye in Maya by using math functions like sine and cosine. He used Maya joins to drive the deformation, and we are going to implement this rig in Houdini by writing a Wix deformer. So the idea is that we can drive the deformation based on a parameter and use this parameter sine function for translate and cosine for scale. So we can see this circle gets its transformation from the sine function and scale from the cosine function, and it always fits this sphere. If we apply this to every point here, we will get the deformation of the iris and pupil the same way as we are deforming here this whole circle. So let's go into our spherical eye geometry. We have a basic sphere. We apply the normals, apply the material, and a simple UV projection, which is just a frontal projection for the whole geometry. And this is our geometry on which we will base our rig. The only thing that's important here is that the radius of the eye is 1 unit. This is so that the calculations are much easier to do with the length of 1 unit. And if the eye needs to be bigger or smaller, we do it after we create this deformation. Okay, so first let's create a rest position, and because we'll need it later, and we'll go create a point triangle, which is actually going to be our deformer. Okay. Well, first we need to add some parameters. We'll need one for the pupil of the eye, and one for the iris, and we're going to use a ramp which will serve as a remap from the Z position. So we're going to call this slide ramp. Okay. And the group of points on which we're going to work with is those that are positive in Z-axis. So we are not worried about the points that are behind here because we'll never see them. So we will deform or slide this iris and pupil by using this ramp. So, and this ramp will be based on the Z position of each point, and we will remap them and use this value to calculate the new position. So we calculate the remapped or value of the point Z position. We calculate the sine value of this position, and also calculate the default value or before the remapped value, which we'll use for the scale calculation, so that we know how much what is the difference for this on the new position and what the new scale should be. So if you do cosine of each of these values. So this is a remap, this is a default, and as is the default and the remapped. So you can actually do it like this. So if we divide our remap scale and default scale, we get the actual multiplication value for the scale, and we simply multiply the points x and y positions, and this gives a scale. So and the point z position is actually just the remapped value of this initial point z position. So now if we change our ramp, we see that we get this sliding effect. What we need now is actually a way to control the iris and the pupil, each one independently. To do that, we're gonna create two parameters, one for the iris edge and one for the pupil edge. And we're gonna have to store 2 point numbers that are resting on this each individual edge. So we're gonna create two integer parameters. I'll call it iris edge and pupil edge point number. Point number for each of these parameters can be any point on this ring. So for the iris, we can just choose 350, and for the pupil 158. And these are constants, so we set them just once and then leave them alone. So now let's calculate the position based on this iris edge point number. So we took the input geometry and based on our iris edge point number, looked up the rest position value in the z value of the rest position. And we are going to copy this and use sort of the same for the position of this third point, which is I'm going to use the pupil edge point number. So right now, if we change the value, we see that we are sliding the each one independently. So now all we need is also to connect this value to the pupil and iris control. To do that, we're gonna write a similar expression and say first we're gonna take from the position value, and we're basically just going to subtract the pupil parameter, the iris parameter. So what it means is that if we change this, we see that it works, and we will do the same for the pupil parameter. So this is actually everything we need to do, and this gives us a nice sliding effect of the iris in pupil. That's it for this video. Thanks again to Chris Lesage for sharing his idea on using sine and cosine for rigging the eye. I hope you enjoyed the Houdini version of it, and hope to see you next time. Bye bye.